Hello, welcome to video number 39, Euclid's proof. This is going to be a very quick video. It's about the proof Euclid came up with to prove that the sum of the angles of a triangle add to 180 degrees. So you know that fact very well, I've heard it many times, but you're also expected to explain why it's true and why it's true for every triangle. So we kind of have to understand how this proof goes. First part is I want to show the plan for the proof, kind of Euclid's basic idea. And like I've mentioned, once you understand the plan for a proof, it's not too hard to write it out. Okay, so here's the plan. We start with any old triangle right here. So that's what we have in the first figure. Nothing special about this triangle. We're not assuming anything about it. Any old triangle would work for this. And what Euclid did is he constructed a parallel line through the top vertex. So this line up top is assumed to be parallel to the base of the triangle. The reason why we can draw a parallel line through that point that's parallel to the base is because of the parallel postulate. It's one of the fundamental assumptions of geometry. It's kind of intuitive, like we saw in class. When you think about it, there's really only one line you could draw through the point that's parallel to the base. Okay, so nothing too shocking. Now, the way the proof goes is we make use of the angles up top. We labeled these two new angles we got when we added the line 4 and 5. And because these three angles form a line, they add to 180 degrees. Now, we want to replace angle 4. Since angle 1 here is alternate interior with angle 4, we can replace the measure of angle 4 with the measure of angle 1. Those two measurements are equal because the angles are congruent. If angle 4 is 40 degrees, then angle 1 is 40 degrees. So we can replace these two with each other. Another one we can replace is angle 5. This angle way up here, this obtuse angle, is congruent to angle 2 because they're alternate interior angles also. So in this equation, we can scratch that out and replace it with the measure of angle 2, and the equation is still true. But what we see is these are the three angles of the triangle. So what my new equation says is that the measure of angle 1 plus 3 plus 2, those are the three angles of the triangle, add to 180, which is what we want to show. So the genius step, I think, on Euclid's part was adding that line. And as soon as we have that, we can show that the angles of the triangle add to 180. Okay, now, we're already at the journal assignment. So your assignment for this video is to complete the reasons and kind of go through the steps. So now we're writing it down step by step, what we just went over in our plan. So we're given a triangle, and it's the same triangle in the previous diagram, and my diagram already shows the parallel line drawn. We want to prove that 1 plus 3 plus 2, the angle, measure of angle 1 plus measure of angle 3 plus measure of angle 2 equals 180. Those are the angles of the triangle. So I even included the first two reasons. What we're given is the triangle. So that's pretty much what the first line says. A triangle with vertices and angles labeled as shown in the diagram. That was given. Then I included Euclid's genius step, constructing a line through the vertex opposite to the base of the triangle, and that's the parallel postulate. Okay, now the other reasons I want you to supply. You may have to go back and watch when we're talking about in the plan, but why do these three angles add to 180? Why is 4 and 1 equal? Why is 5 and 2 equal? And how we arrive at the last step. I think there's a huge hint here. One of the reasons is given right here. One of the reasons is substitution. So you have to figure out which one of those is substitution. Okay, we'll check it in your journals. Have a nice weekend.